Okay, so you are going to have some explanations that you are going to have to explain certain processes on your quiz, okay? So this is describe the M behavior by filling in the blank spaces, state the degree and the leading coefficient, state the domain and range and interval notation for part A only. So your degree is 5, your leading coefficient is 2/5. Okay, your domain for all of these is going to be all real numbers, and your range is dependent on your degree and leading coefficient. You can also use your end behavior to help you with that. So if the degree is odd and the leading coefficient, well, honestly, the leading coefficient doesn't matter for this. If your degree is odd, then the range is going to be all real numbers. That's what it's based on, because it's going to be going opposite directions. It's going to span the entire grid. Okay, so if you have an odd degree, they go opposite directions. Okay, and if you have a positive leading coefficient, that means that it goes up on the right. Okay, so the right side is the second side we do here. The left side is the first side we do. So if it's positive on the right side, as x goes to infinity, f of x goes to positive infinity. And then on this side, as x goes to negative infinity, f of x is going to go to negative infinity, because those two have to be opposite. Okay, and then I want you to talk with your row, and I want you to talk to each other about what you said for the next one. So when is the range not all real numbers? Yeah.
I have no idea.
Okay, and some of you might realize at this point that you skipped that question. Okay, so do not skip that. All right, so what is the range not all real numbers? Who can tell me? Yeah, okay, so if the degree is even, you have two choices, right? It's either going to be 0 to infinity or negative infinity to 0. And that's based on the leading coefficient. Okay, so if the leading coefficient is positive, all of the points are above. They go to infinity. If the leading coefficient is negative, they're below 0. Okay, so that's when you would have the second one. Okay, so that covers all the different cases you can see. Okay, and then the range is this because it's an odd degree. So if it's an odd degree, the range is all real numbers. Okay? All right, and then for B, we have to do the degree and the leading coefficient. You have to say what it actually is. So for degree, don't write odd. You're going to write 3. The leading coefficient is 5. Okay, here you can, and then, okay, so when you do this, make sure you put it in the proper order. So you have negative x to the 4th here, right? Which one is going to be your degree, 3 or 4? Yes, so sometimes they're not in the proper order. So your leading coefficient is at 5 because if this was written in standard form, what would your leading coefficient be? -8. All right, so make that adjustment if you need to. Okay, sometimes it's tricky, right? We get going and we're like, oh, this comes first. So we have to make sure that we're looking at those values. All right, and then now that we have that, if your degree is even, okay, they go in the same direction at the end. And if it's a negative, it's going to fall on the right. Okay, so if it falls on the right, as x goes to infinity, f of x goes to negative infinity, and on the left, it will also go to negative infinity. Did the auto order get you guys, or do you remember? All right, write 2 examples of expressions that are polynomials. So I'm just going to give you a few. This would be a trinomial, quintic. Write something like this. It doesn't have to be in standard form. Or there are polynomials in two variables. Like this would be a polynomial in two variables. It doesn't say the number of variables you have to have. Okay, and then for B, write two examples of expressions that are not polynomials and explain why they're not polynomials. So you have to give me a reason why. So a couple of the main ones we talked about were if there was a variable in the denominator. Okay, so this is not a polynomial. Actually, here, I'm just going to show you mine. Okay, so for this one, it's not a polynomial because you can't have an x squared variable in the denominator. So make sure that you say variable in the denominator. Okay, you can't just say you can't have something in the denominator. It has to be the variable. Numbers are fine. You can also say, or you can't have a negative exponent because technically this is a negative exponent. Okay, and then for this one, here's another main one that you'll have to know. It's not a polynomial because you can't have a variable under the radical. Again, when I am looking for your explanations, I'm going to be looking for key terms. So variable in the denominator, variable underneath the radical. It's important that you mention the variable because you can have a number there. That's fine. It's the variable underneath the radical that's the problem. Okay, so those are going to be the two main cases that you'll have to look out for. Okay, and then when I was checking yours, some of you guys did a nice job too of writing out the negatives. So like you could also write it like this: x cubed plus 3x to the negative 2 plus 1. Okay, no negative variables there. All right, and then for 3, use the graph to state the number of real zeros. So there are 5. 1, 2, 3, 4, 5 times it crosses the x-axis. Okay, the real zeros are the x-intercepts. Okay, and then we're going to do number 4 together. So identify the degree and the leading coefficient. Explain how you know using key terms. Okay, you are going to have to make sure you use some of these terms we're going to talk about right now. Okay, so the degree is even because, hey, who can tell me why the degree is even? What based on the graph lets you know that this is even? Yeah, Liza? But how do you know that? So how do you know it's even? What in the graph tells you that?
On both sides.
Yes, yep. So the degree is even because the ends of the graph go in the same direction. Okay, so this is what I'll be looking for. Degree is even because those ends are going in the same direction. Okay, the leading coefficient is negative. Okay, and Titan, what did you say for that one? The leading coefficient is negative because what part of the graph tells you that? No, the leading coefficient. So we just said the degree is even because the ends of the graph go in the same direction. But what from the graph tells us that the leading coefficient is negative? Yes, that's exactly right. So the leading coefficient is negative because the right side of the graph goes down. Okay, so I want you using words. You can also say that it falls on the right side. So you can say, or because the graph falls on the right. Okay, either one of those would be great. All right. So when you're doing these, I don't want you to mention the symbols. I want you to explain using your words. Okay, so we'll start with the degree of this next one. Okay, so Garrett, can you tell me for B what you said about the degree? Yep, and then why? Yep, so we can say because the ends of the graph go in, and you can say opposite directions or you can say different directions. Okay, but you have to say something about it being odd because they're going opposite ways. Okay, and then the leading coefficient is positive because the graph, you can either say rises on the right or you can say goes up on the right. Either one of those are going to be great. All right, but you have to make sure that you are using those key words. Okay, you have to mention the right side of the graph. Okay. All right, let's see how page 2 went. Okay, so you had a multiple choice question here. Okay, if the end behavior of the polynomial is as x goes to negative infinity, f of x goes to negative infinity. And something I might write out is this is saying on the left, it's going down, and on the right side, it's going up. Which of the following could be f of x? Circle the best answer and explain your choice. Okay, and when you're explaining this, it's going to be based on that if one's going down and one's going up, what do you know about the degree? Yeah, it has to be what? The degree is odd because the ends go in opposite directions, which means I'm going to get rid of every single polynomial where the degree is not odd. Okay, so what's the degree for A? 4. So this would be even, not going to happen. This is odd, so that's still in the running. Okay, this degree is 2, so that's also not correct. All right, and then so this one is odd, and this one is odd, this one is even. So we're canceling the evens out there. Okay, and then the second thing we know is if it goes up on the right, the leading coefficient is positive. Okay, so and the LCO is positive because on the right side, the graph goes up. Okay, so I have a positive leading coefficient with 4. I have a positive leading coefficient with 2. So B and D has to be both of those, so your choice is E. Both B and D there. All right, when you are performing the operations, you have to write those in standard form. Okay, if it's plus, you can find your like terms. You should get 5k squared minus 12k minus 6. For 6b, you do have to remember to apply the negative to everything. I like to do that first, then combine my like terms. If they're like terms, you just add the values in front. So negative 8g squared plus 8g minus 4. Okay, for C, you're going to have to multiply. When you multiply, the exponents go up. So 3 times 4 is 12, x times x to the 5th is x to the 6th. 3 times negative 12 is negative 36. And then x times y squared is xy squared. Remember, when you are writing these, you are putting them in alphabetical order. So the x comes before the y. Okay, so don't write y squared x. All right, for D, when you are squaring something, remember you have to FOIL. So 2a times 2a is 4a squared. Negative 10ab and negative 10ab is negative 20ab. And then negative 5b times negative 5b is a positive 25b squared. Okay, and then for E, if you have 3 of these, you do have to pick 2 to FOIL first. It doesn't matter which 2 you FOIL together first. I just chose the back 2 because I like to distribute first the 3g and then the 6. And then you're going to have to combine your like terms. Okay, so you should have 3g to the third minus 24g squared, because negative 30 and 6 is negative 24. 63 minus 60 is 3g, and then 126. Okay, if you didn't get that correct, you'll have some time here to go back and look at your work to see what mistake you made. Okay, so if you FOILed those 2 together first, that's fine. You just want to be careful about your sign and about your adding because you're switching back and forth. Okay, when you are multiplying 2 trinomials together, I think it's helpful to just write out the first trinomial and then what I'm distributing to, and then writing each one here so I can combine my like terms. Okay, sometimes I had to squeeze some in that didn't have like terms, but when I multiply 4x to the fourth, when I apply that to everything in this trinomial, I have that written out. Same thing when I multiplied the negative 3x squared and the negative 6. And your final answer is 8x to the 7th plus 20x to the 6th minus 6x to the 5th minus 3x to the 4th minus 12x cubed minus 39x squared minus 18. Okay, so I want you to take a moment right now if you need to look that over.